Good morning. I'm Dr. Niti Maheshwari, Assistant Professor, Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I'm going to deliver a lecture on engineering topic, engineering chemistry, the topic being preventive measures against corrosion. We all know that corrosion is nothing but disintegration of the metal surface. And when the metal comes in contact with the environment, whether by the chemically methods or in the presence of moisture and oxygen, it undergoes corrosion. It shows reaction, as a result of which its surface get corroded. So it is necessary to know or study some of the measures which we can take for protecting our metal from corrosion. Now, there are certain things if we do which are going to help us from protecting our metal from corrosion. The first being the proper designing of an object. It helps in the prevention of corrosion. By saying proper designing, I mean to say that if we avoid lots of L, T's and U's, the places where there are corners, then we can prevent our metal from corrosion, or we can reduce the rate of corrosion. Why? Because these shapes at these corners, the presence of oxygen or the concentration of oxygen is less as compared to its outer surfaces. As a result of which, an oxygen concentration cell is developed by the difference in the oxygen concentration, and this formation of oxygen concentration cell accelerates the rate of corrosion. So it is better to use simple designs and not using the L, T's and U's and avoiding these corners. The second general method by which we can protect our metal from getting corroded is the contact of two dissimilar metals must be avoided. And if it is unavoidable, then the anodic area, it should be very large as compared to the cathodic area. Because if we keep in contact the two dissimilar metals, suppose zinc and copper, then they vary in the galvanic series. The metal which is higher in the galvanic series, it start behaving as anode, and the metal which is lower in the galvanic series, it start behaving as cathode. And we all know that the corrosion always takes place at the anode, as a result of which our zinc metal, it is going to get corroded, whereas our copper, it is going to get protected. And if it is unavoidable, then the anodic area should be very large as compared to the cathodic areas. Why? Because oxidation takes place at anode. If oxidation is going to take place, then this zinc, it is going to form zinc ions and release equivalent amount of electrons. And these electrons, they are going to travel from zinc anode to the copper cathode, where they are going to be accepted by copper ions and result in the formation of copper. So if this area, anodic area, is going to be large, then it is going to supply enough electrons which can be accepted by copper ions to form copper. As a result, the rate of corrosion or oxidation is going to be slower. Whereas if this anodic area is small and cathodic is large, then we need a lot of electrons ought to be supplied to the cathodic area so that copper ions can get converted into the copper. As a result of which, the rate of corrosion is going to be higher. The rate of oxidation of zinc will be higher. As a result, the rate of corrosion automatically will become higher. So it is better to avoid two dissimilar atoms coming in contact with each other and exposing them directly to the corrosive environment. The third method is two different metals used in this structure. It should be such that they are occupying nearby positions in the galvanic series. The two dissimilar atoms that we are going to use, they ought to be such that they do not differ much in the galvanic series, so that the formation of anode and the cathode, it can be avoided. Another means by which we can protect a metal from getting corroded is by putting an insulator between the two metal which resist the corrosion. If these two metals are to be used and they are jointly exposed to the corrosive environment, then it is better to put an insulating material like rubber or copper in between so that their corrosion can be avoided. Then, as far as possible, the metal that we are using in this structure, it should be pure, because if the impurities are going to be present, then it is going to lead to the corrosion. That means generally highly pure, 100% is not possible, but 6N is 99.9999% purity. If you are using highly pure metal, then the chances of getting corrosion or corrosion rate is going to be lower. Why? Because in the pure metal only one metal is present. But if there are impurities which are present in the mixture, what is going to happen? There are chances of the formation of the galvanic couple. If our metal is pure and there are impurities in between, then it is quite possible that these metals are up and down in the galvanic series, which may lead to the corrosion of our metal. So it is better to use a pure metal instead of the one having lower purity and addition of impurities. Then if you are using an alloy, then that alloy should completely be homogeneous. By saying completely homogeneous, that is the concentration and the level of the mixing of the metals in the alloy, it should not be very heterogeneous. It should be homogeneously mixed so that the rate of corrosion is reduced. Then the design and the fabrication of the different metallic parts that we are using, it should be done in such a way that minimum edges or corners are there in the metal. Just as I have explained here, the designing should be simple. If the designing is complicated, then it may lead to crevice corrosion. Crevice corrosion is the spaces where the concentration of oxygen is lower in comparison to the outer surfaces. And if on the same metal, the concentration of oxygen becomes different, then it again leads to the corrosion. Now, next method, it is the modification of environment. It also helps in the protection from corrosion. Modification of environment like the de-aeration, that is removing of oxygen by adjusting the temperature or the mechanical aging. So if we remove oxygen from the environment, then the oxygen concentration cell is not going to be formed. As a result, the same metal surface will not function as cathode or anode. So our metal can be protected from corrosion. Then it also involves the deactivation type of things, which involves addition of certain chemicals like sodium sulfite or hydrazine, which absorb oxygen. Again, the oxygen is not present, so our rate of corrosion is going to get reduced. Then dehumidification of the environment can also help in protection against corrosion, and it is dehumidification is done by adding alumina or silica gel. And these chemicals, they absorb humidity which is present above the metallic surface. In addition to these, there are certain chemicals which reduce the rate of the corrosion. These chemicals are known as corrosion inhibitors. Since anodic and cathodic surfaces are formed, again these are inhibitors, they are of two types, anodic and cathodic. What does these inhibitors do? They react with the ions which are formed at the cathode or anode. They react with them and they get adsorbed over the surface. So these anodic and cathodic inhibitors like phosphates, like chromates, like tungstate, also like thiourea, substituted ureas, these are the cathodic inhibitors and these are the anodic inhibitors. They react with the ions which are formed at the anode and the cathode, result in the formation of the precipitate, and the precipitate, if this is the cathode and this is the anode, the precipitates settle down on the surface of the cathode, and those which react with the ions which are present at the anode, they get absorbed over the surface of the anode, and once they both cover the cathode and anode, obviously the rate of corrosion is going to get reduced because the ions or the electrons are not able to flow from anode to the cathode. Another method, by use of the salts of magnesium, zinc or nickel, the insoluble hydroxides of these metals, they also help in the prevention of corrosion. So these are general methods by which we can protect our metal from corrosion. Now, coming to another method, the cathodic protection or the electrochemical method. For the protection of large structures, the underground pipelines or the ships or the submarines, we use the method of cathodic protection. Now, what is corrosion? It is the oxidation of metal to form metallic ions. There are certain reactions which are involved in corrosion. Now, the reaction which is taking place at anode is the metal, it forms metallic ions and release equivalent amount of electron. That is, the metal undergoes oxidation. Whereas these electrons are accepted by the ions which are present at the cathode to complete the reaction. In this case, I am considering an acidic environment. In acidic environment, we get H plus, and these electrons are accepted by H plus to release hydrogen gas. Now, by cathodic protection methods, what we do, if we provide electrons from an external source, and we force our metal not to behave as anode, but the metal to accept these extra electrons, but we force our metal to accept the extra electrons from another source and form the metallic structure back. This is the basis for cathodic protection. What exactly we do? In actual practice, when corrosion is undergoing, our metal, it releases metallic ions and electrons. But if we supply excess of electrons from an external source, so that our metal, it accepts those electrons, and these electrons are in excess to the corrosion electrons. So they are going to accept the electrons from an external source, and these metallic ions they are going to again get converted back to the metal. So this is the basis for cathodic protection. And the first method we use for the cathodic protection is the sacrificial anodic protection. And this method, it is used for the underground steel pipes protection. So the buried pipelines, they are protected by this method. What we do in this diagram, this is the ground level that I am showing here. This exactly is the ground level, and this is the buried metallic pipeline. So this is the buried metallic pipeline. We connect our metallic pipeline through an insulated copper wire to another anodic material, and this material is more anodic than our metal. For example, zinc, aluminium or magnesium, they are more anodic than iron. So if I connect my iron pipe with these anodic metals, then these anodic metals, they are going to supply, instead of this iron providing ferrous ions, these metals, they are going to release excess amount of electrons, and these electrons are going to travel from anode to the cathode, so that the ferrous ion accept these electrons and get back converted into the iron. And since these metallic ions are being sacrificed for protecting our metal. Therefore, it is known as sacrificial anode. So, in this method, what we do, we are going to connect an anodic material which can supply excess amount of electrons through wire to our metal, which is going to be protected. And when the flow of electron, instead of iron giving the electrons, in a reverse direction, we are flowing the electron, and this current is greater than the corrosion current, and hence our metal is going to be, or iron is going to get protected. So, in this case, a magnesium rod, it is fixed under the metal under protection, and both are connected via conducting wire. And magnesium, it is more positive than iron, and hence in the electrochemical series, it is going to act as anode, and the iron is going to act as cathode. And we know that in corrosion, it is always the anode which is going to get corroded, and the cathode is always going to get protected. So, here, according to the principle of galvanic cell, it is anode which undergoes oxidation, and hence corrosion occurs at anode, saving the iron which is acting as cathode from corrosion. The second method of cathodic protection is impressed current cathodic protection. What we do in this case, we connect our metal which is to be protected through a DC source through another insoluble electrolyte. Now, this can be scrap iron, or this can be platinum, or this can be graphite. These material that we are adding, they need not be anodic materials. They can be any materials which can supply electrons to our iron surface. Now, here the object to be protected is made cathodic by connecting it to the negative terminal of a direct current source, and the positive terminal of the source, it is connected to the other electrode made up of graphite or platinum or lead or nickel or the scrap iron. And the impressed current is the current which is flowing in opposite direction to the corrosion current. So, the impressed current opposes the galvanic current, that is the corrosion current, and hence protection from corrosion takes place. So, again in this method, I am using the ground level iron pipe. We are connecting this iron pipe by a direct DC source to an electrolyte, and to an electrode, and this electrode is able to supply excess amount of electrons to the iron. So, again by this method, we are able to protect our large structures. So, cathodic protection methods, it is utilized for the protection of huge structures. For the smaller structures, we can do by the inhibitors or by using the coatings. The next method by which we can protect our metal from getting corroded is by the use of metal coatings. Now, since metallic coatings again are of two types, anodic coatings or the cathodic coatings. Now, taking first the anodic coatings. Anodic coatings are such where we are going to coat our metal with another metal which is more anodic in nature, or which is higher in the electrochemical series than our metal. For example, if this is the iron which is to be protected, so this is our base metal, and if I want to protect this base metal from getting corroded, then I am going to cover this coat this metal with another metal, and here I am going to use zinc. And this is a very common method which is galvanization. So, coating over zinc over iron. And if we see in the galvanic series, according to galvanic series, this iron is going to function as cathode, and zinc being higher in the electrochemical series, it is going to function as anode. So, our corrosion is going to get concentrated at anode. So, in this case, when we expose these metal to the corrosive environment, since zinc is covering our entire iron, so this zinc is going to undergo corrosion and release electrons. Whereas, since iron is cathodic in comparison to the zinc, it is going to accept the electrons and it will remain cathodic. Even if this coating is broken from certain places, even then the iron will not get corroded. So, zinc keeps on getting corroded and it is going to protect our metal from corrosion. So, coating of zinc over iron is anodic coating, and this process is also known as galvanization. Zinc, it occupies a position before iron. In this process, the base metal is immersed in molten coating metal. The base metal should be very clear. So, anodic coatings of iron is also done by aluminium and cadmium. And if there are any cracks or breaks in between, even then these metal, they will act as anode and they are going to protect our metal iron, which is acting as cathode. So, here you can see, here again it is seen that this is the base metal steel and we have an coating of zinc over steel. So, even if it is getting exposed, here you can see that the coating is broken down. Even then, the metal is functioning as cathode, whereas this is a corrosive environment and our zinc is just getting oxidized and releasing equivalent amount of electrons. So, but zinc in itself is toxic. So, we cannot use galvanized utensils for cooking and other purposes. But here, zinc, it is being sacrificed for the protection of iron. Therefore, the galvanized iron, it is used for as buckets or as tubes or as roof sheets. Next type of coating is cathodic coatings. Sorry. Now, cathodic coatings are those in which the base metal is more anodic than our coating, and we are going to protect our metal from getting corroded by the less active nature of our metal. So, cathodic coatings of the base over the base metal is done by another metal which occupies a position below it in the electrochemical series, and it is going to be corrosion resistant. For example, if I coat our metal with tin, then tin is lower in the electrochemical series, but it has lower activity or reaction also towards the environment. Therefore, it protects the surface of the metal because it itself does not interact with the environment. But these cathodic coatings, they protect the base metal only when these coatings are continuous in nature. If these coatings are broken down, if there is a break or discontinuity in these coatings at any places, then you can see that our coating is behaving as cathode and our base metal is behaving as anode. If the coating is broken down, then our metal is anode and we are giving a suitable environment. And we all know that the corrosion always takes place at anode. So, if the metal gets exposed, then the corrosion rate of iron is going to be very fast. So, these coatings are only functional if it is in continuity. So, here the coating of tin over iron, it is an example of cathodic protection. And the cathodic protection of iron, it is successful only when there is no crack formation in the on the surface of the metal. And this process is also known as tinning. The difference between galvanization and tinning. That is the difference between when we coat our metal over with an anodic metal or with a cathodic metal. So, in the case of galvanizing, It is a process of covering iron or steel with a thin layer of zinc, whereas in tinning, we cover our metal with the thin coating of tin to prevent corrosion. Sorry. The zinc, it is going to protect the iron sacrificially, but the tin, it protects our base metal because of its noble character, because it does not react very much with the environment. Next, the zinc prevents iron even when the coating is broken down or it is punctured. But if the coating of tin is punctured or it is broken down, then we cannot protect our metal from getting corroded. Since zinc is toxic, we cannot utilize this type of coating in case of utensils. But tin, since it is non-toxic, then we can utilize it in containers for even storing the food material. Another method is the metal cladding. Metal cladding is nothing but it is a process of sandwiching our metal which can undergo corrosion between two corrosion resistant metals. So metal cladding is, if this metal is to be protected, then we have to cover this metal by two different metals. So we are sandwiching, forming a sort of sandwich where this metal is going to be protected by another metals which are corrosion resistant. Now here, duralumin is getting protected by a covering of aluminium above and below. We all know we use aluminium utensils. Why? Because aluminium in the presence of oxidizing environment, it forms a very thin layer, oxide layer on its surface. And till the time the environment is oxidizing, this oxide surface is going to protect the utensils or the things of the made up of aluminium. So different metals like nickel, lead, copper, aluminium, silver, platinum, they are being used as cladding material over the base metal. So this is another type of method where we can protect our metal from getting corroded. Corrosion inhibitors. Now, according to the surface chemistry, the presence of foreign molecules, they affect the surface reaction. So corrosion, it is also a type of surface reaction. Here, these can be controlled by the foreign compounds which are known as inhibitors. Now, I've already discussed that inhibitors are not, they do nothing but they get absorbed on the reacting metal surface. And when they get absorbed, they attaches themselves directly to the surface and absorb up to one molecular layer. So if this is the anodic surface, these inhibitors, they are going to get absorbed over the anodic surface, hence covering the anode or preventing the anode from directly coming into contact with the corrosive environment and not in bulk of the metal surface. This is a well-known method for controlling the process of corrosion. These inhibitors, they can work in different manners. They may block the active sites of corrosion or they may restrict the rate of anodic or cathodic process. If we are going to cover, obviously, if you are going to cover the requirement or the release of electrons, it is going to get reduced, or thereby increasing the electrode potential. So they can work in different manners. The xylamine or the sodium benzoate, they are used as inhibitors for anodic reactions. Similarly, the oxidizing agents like nitrites, like chromates, like amines, like thioureas, they are also used as corrosion inhibitors. So there are different types of inhibitors. Those which can react with the ions are present at the cathode, they are the cathodic inhibitors, and those which react with the ions at the anode, they are the anodic inhibitors. And once the cathode and anode, they are covered by the inhibitors or by the precipitate, their surface is not exposed, hence the rate of corrosion gets reduced. Thank you.